This is Algebra 1, Term 5, Lesson 13, Mixed Review. We'll begin with a Desmos activity, and then we'll come back to slides to work on some GeoGebra tasks, and we'll finish up with function analysis. Let's get started in Desmos. So this cumulative review is lengthy. As you will see, it has 27 screens, and it does cover a large number of standards. The majority of these screens are self-checking. On this one, they're going to create a line of best fit. When they do get it correct, it will say success, so tell them, be sure it says success before you move on. And then the questions will pop up in the response box, and they'll just type here next to questions 1, 2, 3 their answers, and they will share with the class. You may want to paste them here so that you can discuss any misconceptions students may have. For this one, they're going to create an equation for a line that contains the points in any form. So as long as the line intersects the 2 points, it will be counted as correct. So this screen is solving equations, and they will type each of their steps into the table. They may not need to use all of these rows. Something you might want to know about this screen and several of these first screens is that this is not just one question, because when they finish, they have the option of clicking to get a new equation and doing these again. And some of the graphs are the same way. This is an example of a system on screen number 4, and they could solve several sets of equations. If they don't like their set, they can get new equations. You'll also notice that when they move this up, the graph will adjust to fit, so they can get that on there. These are kind of a pain, I'll just be honest. Graphing these is challenging, so tell them not to get too excited about it if they're not able to get those points exactly where they want them. I did give them the graphing calculator, so if they need to graph them there and then use that to help them make sense of this graph, that would be great. The goal though is to get the graph and to show the solution, so the lines really should be graphed correctly, so tell them to do their best, but after a while, if they're struggling, just let them move on. In this one, they're using properties of exponents, and they're grabbing these numbers and placing them into these spots, and when they do, it will appear here, and then it will show them at the end if it is correct. So this one is also self-checking. Same thing here, but now we do have a -1 as an option. Okay, now we have two functions, h of x, which is quadratic, and g of x, which is linear, and what values of x will make h of x equal to g of x. Now they can solve this algebraically. They can also solve by graphing. Here is a transformation of the absolute value parent function, so which equation would represent the new function. I really like this one. They're going to grab these red points and they're going to place them on the graph to show where the zeros of the function are, and then they will submit. If it is correct, an image will appear to confirm their answer. All right, here we have 3 different quadratic functions. We have the graphs, we have the equations, and then we have some descriptions. And this has to do with the zeros of the function. This is also self-checking. It will tell them when they get all of their cards correct. Now we have a function, and we're just evaluating the function at a value. Definitely they can type this into the graphing calculator and input f of -4 on the next row, and it will evaluate for them. Here we're graphing a line. Here they're given a function and asked to write it in factored form, and then choose a binomial that could represent one of the factors. Here's an equation. It is a quadratic equation. What are the solutions? Now they could graph, they could use factoring, they could use the quadratic formula. What is the solution to this system? You may notice it says to insert a photo of your work. What I would have the kids do if they did do the graphing in the graphing calculator is they would take a picture of that graph and insert it in the box where it says explain. They'll have a space to put a photo. Here's a system of inequalities, and they're going to choose the ordered pair that represents a solution to this system. Here they have another system of inequalities, and which graph represents this system. Now they're going to solve an inequality, and after they submit, they will insert a picture of their work. For this one, I would have them work it out on a mini whiteboard, and then when they take a picture with their device, they can upload it into the box when it says to explain. Consider this quadratic equation Write an equation in a form that reveals the y-intercept of the graph. So hopefully they know the name of this form is vertex form. So which form would it need to be in to reveal that y-intercept? Here we have an application problem and we're finding the rate of change using data in a table. Here they're given a function and they're to classify the function. Is it linear, quadratic, or exponential? Once they've chosen that, some points will pop up in the graph and they will click and drag on those points to create a graph to fit the function. It will let them know when it is correct. The graph of this function is transformed to create the graph of this function. Classify the function by clicking one of these buttons, and then you will click and drag in the graph to create a graph to fit g of x. Here we have a standard equation with the variable m. To solve the equation, they will write it out on a whiteboard. Now this is one we've never done before, so this is brand new. The 3 green points that are in this graph fall on a quadratic function graph, which hopefully they know that is a parabola. Where would the line of symmetry have to be? I'm not going to say anything about where it is here, but if you look in your teacher moves, I did give you a clue as to where they should look. Most kids will find this just by experimenting. So they will drag this point, and when they do, they'll have 2 points, and then they're going to drag it over here. Let's see if they can put it in between all those points and make a line of symmetry. This might be a good screen to pause on and get all the class together, maybe come back together to have a conversation about. It's a good opportunity to really think about what symmetry means and how this graph could help you, how these points can help you figure out where the line of symmetry must be. Right here we have an inequality and we're told to move the green points so that the graph of the line that connects those green points will satisfy the equation 5x plus 6y equals 30. So they'll just graph a line by plotting 2 points. And then they decide, do you want the line to be dashed or solid? And it will draw the line to connect the points. And then you will say, are the solutions above this line or below this line? And then they will check. It will check each of those components individually and give them a check mark. So if any part of that is wrong, it will tell them and then they can correct it. For this one, they are given the equation of the line 4x plus 5y is equal to 20, and they are selecting 2 points out of the blue ones that are solutions to the inequality, and they simply drag the little red dots into the blue circles to select the points. Once they've selected their points, they will click on submit and it will confirm if they are correct. And the last screen is bacterial growth. So the students will choose a number for the initial population of bacteria. I did bold this word thousands. It was not initially bolded by the person who wrote this, so it may or may not be on the end of course exam. So they really do need to read carefully their questions. And then the population, is it increasing or decreasing, and what percent? And this concludes our Desmos activity. Let's head on back to slides. So when you get back to slides, you're going to go to your GeoGebra tasks first, and there are 4 of them. Each of the tasks has a separate app. So notice you have this equation. You're going to go into the GeoGebra app and you're going to recreate that equation. Now the fun thing is you don't see that equation here. What they're doing is they're rewriting the equation as a piecewise function. I'm not going to graph this one. I'm just going to do a random function here to show you what it looks like. Once they've created the graph for their equation, they'll have a piecewise function to go with their graph. They will take a screenshot that includes the graph and the piecewise equation, and they will place it on this slide. And then they will answer these questions. What is the vertex? What is the domain and range? You'll notice it doesn't say type here because the domain and range for most of these functions is going to have a less than or equal to or greater than or equal to, and that symbol is kind of hard to find. It's not on the keyboard. So I have them write that on a whiteboard and insert a picture onto the slide for those. What does the vertex represent? Is it a maximum or a minimum? What is f of 0? And over what interval of x is this function increasing? How does this function compare to the parent? They may notice the interval of x where the function is increasing is actually one of the domains for one of the pieces. So that could be a conversation you could have as a class. At the bottom in their show notes, it does tell them insert images of the graph with the piecewise equation, the domain, and the range. So those, again, are going to be written on a whiteboard so that they don't have to fumble around trying to find those symbols. So for GeoGebra Task 2, we're going to go to a different link, and we're going to create this function. And so notice all we have to do is move the sliders to fit the function that was on the slide. So they'll just move these. I'm just creating a random function. This is not the same one. But anyway, once they've created their function by sliding the A, B, and C, they'll take a picture of that and they will insert it here. And then they will tell what is the vertex. Does the vertex represent a maximum or a minimum? What is f of 0? Over what interval is this function increasing? What are the zeros? And then they're going to write this equation in vertex form and in factored form. And they will insert that equation onto this slide. Absolutely, they should check their equations in Desmos to make sure that the original equation, the vertex form, and the factored form are all producing the same graph. On task 3, something completely different. They're going to do an algebra tile model. So go to GeoGebra. They're going to create this polynomial here. And once they create it, they're going to click here to complete the square. And it will actually show them the entire process, create their algebra tile model, and then take a picture of it and insert it on this slide. They will write the equation in vertex form, which should be pretty easy because the app did that for them. They will create a graph for the function, so they will go to Desmos, make the graph, and insert it. What is the vertex? What does the vertex represent? A maximum or a minimum? What is f of 0? And over what interval of x is this function increasing? For task number 4, they're going to go to GeoGebra and create the function f of x equals 0. So you'll notice there's no f of x in here. It's equal to 0. So they're going to put their function here by using sliders. And once they do that, I'll just make up some random numbers. I don't think this is right. Click substitute values and then just let it do its thing. It will substitute the numbers in, and then down at the bottom, these purple arrows will help you advance through the problem. And so they'll put their solutions. Those are not the solutions, by the way. I think I gave them nicer numbers. I can't remember. Classify the solution. So they're going to tell me all the different classifications for the numbers that are their solutions. They will create a graph for the function. They will tell me what the x-intercepts of their function are. They will write an equation in factored form, and they will tell me what f of 0 is. Finally, we're going to do some function analysis, and for these, we're kind of going in reverse. We're given a graph, and we're going to create an equation to fit. So classify this function. What is the domain and range? What is an equation for the asymptote? Is this function increasing or decreasing? And what is the growth decay / decay? They really need to decide if this is growing or decaying too, so that would be important. They've already answered if it's increasing or decreasing, so that's a clue. They will insert a whiteboard with the domain and the range and the equation of the function. And some students may choose to use a regression equation to create this, and that is absolutely okay. It really is. If they don't remember how to do this without it, then they should. Function analysis 2, we're going to classify this function. We're going to create an equation. We're going to identify the domain and the range. Is it increasing or decreasing? Does this endpoint represent a minimum or a maximum? And how does this function compare to its parent? The stuff that's in blue is what they're going to insert pictures of on this slide. For function analysis 3, classify this function. Create an equation. What is the domain and range? Over what interval of x is this function increasing? Now here's a little different. We're going to write and solve an equation to find the exact values for the x-intercept in simplest radical form. So whatever their equation is, they're going to change their y value to 0 and solve to find those x-intercepts. This is an opportunity to simplify square roots, and there's not really any of that in this activity other than that, so let's get the most we can out of this particular problem. And the last question is function analysis 4. Classify the function, create an equation. What is the domain and range? Over what interval of x is this function increasing, and how does this compare to its parent? If you want, you could have them actually write a linear piecewise equation for this graph as well. They're already writing an equation, and maybe some student will do it that way, and that would be fine. So an absolute value function or a linear piecewise function will work. As always, the teacher's slides will provide detailed answer keys for each of the tasks in this lesson. And this concludes our mixed review. We only have one more lesson before our benchmark exam. Y'all have a great day.